AI research is moving so fast that before you blink, there's a new development. At this rate, general intelligence might not be as far away as we think. In sci-fi movies, general intelligence is portrayed brilliantly as humanoids, like the friendly robot in Star Wars C-3PO and the virtual assistant Jarvis in Iron Man. These machines can completely replicate human intelligence, the ability to hear, feel, read, think, and make typical human responses to stimuli. Some can even read and display emotions. Although general intelligence is currently nothing more than a fantasy, AI researchers have started developing multimodal artificial intelligence models. In data science, multimodal is a word used to describe any AI model that can process more than one form of input. Kosmos 2 is a multimodal AI model with features that allow users to throw questions at the machine in the form of text and images. To be clear, the Kosmos 2 we are talking about here isn't the satellite launched in 1962 by the Soviet Union. Although competing AI models recently introduced multimodal features, there's something special about Kosmos that puts it ahead of other competing models. That's what you're going to find out in this video. Before Kosmos 2, development in multimodal language models couldn't do more than accept user input in texts, perform necessary computations, and churn out answers in the form of texts. But as development in language models started to advance, new models were introduced that could receive other types of inputs beside text like images and audio. Kosmos 2 is an advanced version of Kosmos 1, an AI model also developed by Microsoft Research that can accept a combination of text and image data. Is a multimodal large language model that refines the capabilities of its predecessor by introducing something called grounding. Grounding allows the AI model to go further than just image recognition. This new feature makes it possible for the models to ground images in the real world. Grounding streamlines the human-AI interaction and is essential to actualizing general intelligence. In earlier models, the interaction between the AI system and the user was bumpy. Imagine if you wanted to call an AI's attention to a particular object in an image. It will take many words to describe the instruction to the computer. While other multimodal language models like GPT-4 can identify objects in an image and understand how they relate to each other, they cannot graphically show the position of each object. But thanks to grounding, you can target specific objects in an image instead of going through the hassle of describing it over text. At the same time, text-only answers can be vague and limiting. Kosmos 2 also uses grounding to enable the model to highlight certain objects in a picture by drawing a boundary box around the object, allowing it to give more comprehensive answers and a solid context around its response. Pictures do say more than 1,000 words. Here's an example to show how grounding can be very helpful. Let's say you wanted the model to identify an item in a photo you don't actually know. Imagine explaining that to the model through text. Sounds tedious, doesn't it? With Kosmos 2, you simply draw a rectangular box around the image and ask the model to identify your selected object. The fact that an AI can pull this off sounds quite fascinating. Kosmos 2 is actually built on the Kosmos 1 language model, and the Microsoft team is behind the design of both projects. What separates Kosmos 2 from the earlier model is the fact that it learns using grounded training data. Kosmos 2 is trained using a large data set of images and corresponding text describing its content from the web. To ground the image-text pairs, the developers at Microsoft Research perform some interesting computations on each item in the dataset. Every noun phrase in an image's text is linked to the object's spatial position in the picture, which is graphically enclosed in a bounding box. For instance, the part of an image caption saying, "the engineer's hat," is linked to the spatial position of the hat in the picture. Next, the developers convert all objects obtained spatial locations to location tokens. They create a grounded dataset containing reference text sequentially and its corresponding location in an image. By doing so, the objects or regions of an image become hyperlinked to their captions. According to the white paper, a single picture contains 32 by 32 location tokens. The model uses location tokens to see what regions of an image a user refers to, associate them with certain nouns in a user's question, and give visual answers with bounding boxes around certain parts of an image. Basically, the model uses these location tokens to find the object referred to in a user's request. These same location tokens allow the AI to point at certain objects by drawing boundary boxes. One can see how grounding makes communication between humans and AI models easier. After realizing a grounded text-image dataset, the developers trained the model. To efficiently train the model, the developers fed it with 25 billion tokens, achieved by running 60,000 steps through batches consisting of the following types of tokens: 215,000 tokens of original and grounded image text pairs, 185,000 tokens of authentic texts, and 19,000 tokens from interleaved data. Despite a massive amount of dedicated computational power, the training took an entire day to complete. At this stage, the model understands how to recognize and identify objects in an image. However, it still needs to learn how to answer users' queries. That's where instruction tuning comes in. Instruction tuning is the process of teaching the model how to respond to user requests. To this end, they give the model millions of instructions from several sources. The developers created grounded vision language instructions and imported thousands of language-only and original vision language instructions from other libraries to tune the model. Finally, they evaluate the model's vision language capabilities with phrase grounding and referring expression comprehension tasks. We'll find out what that means in the next section. Phrase grounding is the ability of the model to receive an image caption, isolate the noun phrases, and predict the location of its bounding box. Look at this picture with the caption, "A man in a blue hard hat and an orange safety vest," for example. Suppose we send this picture and its corresponding caption to the model prompt. In that case, it breaks it into phrases and pinpoints the location of its noun phrases: a man, a blue hard hat, an orange safety vest, then generates its location tokens. The model responds with the location tokens, and the Kosmos developers design a program to decode the tokens and output bounding boxes at different locations of the original image. Microsoft ran benchmark tests on Kosmos 2's phase grounding performance compared with other multimodal models using Flickr 30K. Kosmos 2 outperformed Grill, but didn't stand a chance against other models using post-processing to ground text to images. From the results, we can conclude that Kosmos 2 does a decent job grounding phrases without post-processing. Referring expression comprehension is the ability of the model to identify the object referenced in the text. It's like phrase grounding, except instead of predicting the position of all the noun phrases mentioned in an image caption, the model only looks for a single object described by the entire text description. Let's use an example also used in the white paper to explain. If this picture of 3 cows laying on the grass is submitted with a text prompt instructing the model to find the frontmost cow to the right of the other cows, it generates the necessary location token of the cow and encloses it with a bounding square correctly identifying the referred cow. Unlike earlier models, which only give full text descriptions of the image submitted, Kosmos 2 can actually generate bounding boxes around the image described by the user. Microsoft developers did zero-shot and few-shot tests with Kosmos 2 and compared the results with other fine-tuned AI models using RefCOCOG. Kosmos 2 displayed impressive results. In the zero-shot tests, its CIDER rating was higher than fine-tuned SLR by 1 point. After giving the AI model a few sample pictures to work with, its performance improved further, showing Kosmos 2's ability to exhibit contextual learning. Microsoft research took us one step closer to realizing general intelligence with Kosmos 2, a language model that grounds text to the visual world. If you're curious about the next big leap in AI, subscribe to our channel. We cover all the latest developments in the ever-expanding world of artificial intelligence.